Okay, so here is the last part, which is really the first part. Sorry, Lily. Okay, so this would have made more sense because it did kind of start tricky. So match the piecewise function with its graph. So this has x minus 4 if x is less than or equal to 1, 3x. So sometimes when you have matching, you kind of want to take a broad, especially if you're timed. So like this I know is going to be the point, it's going to be like a y line. Negative, I hate when every point is 2 because I was looking for 2.5, but it's actually -5. So this is -5 for x less than -1. So I'm going to kind of match by doing that. So I know that this is C. And then this flat line is for -5 for x greater than +1. So that's this guy. So this is going to be A. So then I know that I'm done with that one, and I'm done with that one. And I already used that one. So before you start like looking around at slope, do the easy ones, especially if that's on your test too. So then we have, then I would kind of knock out like a negative slope, which positive, 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 positive. Okay, so they made that, these all positive. So that's what I would look for next, like if any of these were negative sloped, because then you can knock that out. But anyways, so this is, this both is meeting at 0. So I know it has to be this one or this one. So I'm just kind of like having you knock off, like when you have the option to knock off multiple choice, you want to do that. So this is the line for x greater than or equal to 0. Like remember these go by 2's, which drives me crazy because you're kind of used to slope going up by 1. So really this is up 2 over 1, which is up 4 over 2. So that has a slope of 2. Okay, and it starts at 4. So this is looking like this 3 is graph B. Alrighty. So then this one also met, and it was this starts at 3, so I know that it's that one. And then you can like double check with the slope, but that works. And then this is x plus 4 for x less than 0. So this guy is looking to be for number 2, F. So then we have, then you can just kind of do whatever you want to do. I just try, when you've got matching, I try to eliminate the easy ones first. And then also, if you have something to like cover it up with so that you don't choose any of these, that'll kind of like eliminate some of the the noise, so to speak. All right, so if you just wanted to like kind of like really focus on one graph, then you could do that. So like this graph, it starts, this y-intercept is -2. Okay, so then I'm looking for like an intercept of -2. And then I can kind of make sure that that slope is down 3 over 1 for x less than or equal to 1, which is it. So 5 is D. And then just, I know students always like just say like, oh, it's the last one. But, you really should double check. So it does start at -4. It's got a slope of 1 for x less than or equal to 1. So that's that guy. So hopefully that's not too fast. I mean, if you want to pause it or we could talk about it later. But that was those puppies. Then we have carefully graph each of the following. Identify whether or not the graph is a function. Then evaluate the graph at any specified domain. So be careful here. I still feel bad in the last one. It's a function. It must have a 1-to-1. So that means for each input, there's one output. I'm just kind of squishing that in the the thing. So that's called a one-to-one correspondence. All right, then evaluate the graph at any specified. So evaluate means you plug in. So we don't have to graph it to determine if, you know, you can do the algebra piece first. So f of 3, it's going to fit under this domain because it's greater than or equal to -1. So I'm going to have -2 times 3 minus 1, which is -6 minus 1, which is -7. So like 3, -7 would be a point on that graph. The f of -4, that's less than -2. So I'm going to plug it in. -4 plus 5 is 1. So that means that -4, 1 is a point on that graph. -2 is not going to fall in here. So this does not exist at that point. So again, your teacher might be telling you to write, you know, something else, or like not in domain or something, or not specified. I don't know. Some people just say different things that kind of mean the same thing. Don't say no solution because you're not like solving anything. All right, so the domain you could get algebraically. It's going to be from -infinity until I get to -2, not including, and then pick up again at -1, including to infinity. And then the range I usually do from the graph, so we'll look at that in a second. And so we'll just graph this. So let's plug in -2. So at -2, I would get an output of 3, 1, 2, 3. And then I would just pick up with my slope. So down 1, it's a positive slope. Whee! So it looks like that. And then this one, if I plug in -1, I get 2 minus 1 is 1. So sometimes that's kind of hard to see with all those negatives. So that's going to be +2 minus 1, which is 1. So -1, 1. I think I was doing that. Closed. And then pick up where you left off. Now, if you want to just graph it, like you would start at -1 and then go, you know, down 2, right 1, down 2, right 1, which is what I'm going to do when I pick up from that point. But just if that's any easier for you, doing sort of like the endpoint way. All right. So this range then is everything. And it stops at 1, 2, 3. So it's from -infinity to 3. Open. Okay. Now sometimes you might look at that break, but there's still output values in there. The domain is what has a break. Okay. It is a function. All right. So I'll send you that vid. Sorry. And then we'll chat. Okay. Bye.